Hello everyone, and welcome to part 2 of the 3.4 notes, where we are talking about finding the zeros of a polynomial, which is the same task as factoring a polynomial, by using division instead of by normal means. Because here, factoring a polynomial like this, what we see in this example right here, this polynomial for 1, it's to the 4th power, it's a 4th degree polynomial, and there are no common factors between any of these terms, or at least we for sure don't have a common factor between all of them. And it's got 5 terms, so we can't even try doing it by grouping. If we don't have this technique of using the division, we're going to be pretty stuck trying to factor this one and find the zeros. And so what we will try first to find the zeros for this polynomial is that we should list all of the possible zeros. And so remember, the possible zeros will go like p over q, where the p should be a factor of the last term over here, 3, and the q should be a factor of this first coefficient for the first term, the leading term right here, which is 2. So we should have any of our rational zeros will be written in the form of a factor of 3 divided by some factor of 2. And so we could actually list what are the possible ones. Possible rational zeros are all the ones of that form. So we could have, for example, the factors of 3 go 1 and 3 actually. Those are the only factors of 3 because, of course, 3 is a prime number. Also, 2 is a prime number, so the only factors of 2 are 1 and 2. And so if we come up with all the combinations of putting one of these numerators over one of these denominators, 1 over 1 we could get 1, and we should do plus or minus, of course, because, for example, negative 1 times negative 3 also gives you 3. So we want to include the negative case. Also, we could put 1 over 2, so we could get plus or minus 1/2. 3 over 1 will give us plus or minus 3, and then 3 over 2 will give us plus or minus 3/2. Now, we don't have too many to choose from here to start doing with this synthetic division. The first one that I want to choose, just because if you take a look at this function, you can try to make an educated guess about which one of these might be a 0. And you could even, since we have such a small finite number of possibilities over here, you could even look at these, see if you could try plugging them in, working it out in your head, and maybe you can guess one of the first zeros. But I just want to try it with 1. I want to divide using 1 as the divisor for this one. And when we say 1, of course, what that means is that we're taking this thing f of x and we're dividing it by x minus 1. And we're going to see what happens. We're going to see whether x minus 1 is a factor of this by seeing whether or not we get a 0 as a remainder at the end of this process. And so first, when we do this synthetic division, we make sure that we have all the terms there, or else we need a placeholder of a 0 somewhere along in here. And there are no missing terms, so we should just come in here with the coefficients 2, 1, negative 5, negative 1, and 3. And then we will do the synthetic division. So bring down the 2, go 1 times 2 is 2, add them up, and then we go 1 times 3 is 3. We'll add these, get negative 2. 1 times negative 2 is negative 2. We'll add them up and get negative 3. And then do you see what's happening? 1 times negative 3 is negative 3. We'll add them and we get 0. So sure enough, one of the zeros for this function actually is 1, because we have confirmed that this thing x minus 1 actually is a factor of this polynomial. Now, when we try to divide again, there's no need to actually, if we're going to use synthetic division again, we do not need to use this line again. We don't need to use the original function, because we already found out a way that we can write this function again. Do you see? This one corresponds to a function that has coefficients of 2, 3, negative 2, and negative 3, but the powers are 1 less than all of these. So instead of 2x to the 4th, this 2 means 2x cubed. Then it goes plus 3x squared minus 2x, and then minus 3. And it would be a waste of time for us to actually try to divide the original by another factor, because we already found out that we can write f of x as this thing and then times x minus 1. So if something is going to be a factor of the original polynomial, it better be a factor of this new polynomial that we have that now is 1 degree less. And actually, since we have a polynomial now that's a cubic, and there are 4 terms, it might be possible to do this without doing synthetic division. We might be able to just factor this one. And if you look at this one, actually, yes, it is factorable. But what I was meaning to say is we do not need to use the original again. In the event, we do not need to use this original again if we found a factor already. If we found a factor, then we would like to just use the new one. Use the new polynomial that we got, which is basically, it's not a new polynomial, it's just what's left over after factoring out this factor that we confirmed is there. And so this will save us some time, save us some effort, and it's definitely the best practice. And so we could do this one. We could try dividing again by one of these zeros. Recognize it's also possible, this will be a little note, you might need to try to find the same factor again. So we would maybe be interested to try to divide it by 1 again. Try the same factor more than once is possible. There's no reason why we should only try to divide by 1 right here, only one time. It might work again, because here we're interested in this idea of the multiplicities. If the multiplicity is more than 1, that means that the same factor appears more than once, and so you actually would be successful if you tried to do synthetic division again with the same factor. And so we could do it, but like I said, why don't we just factor this one? Do you see how we can factor it? What about by grouping? It goes 2x cubed plus 3x squared. We can group these. And then I'm going to factor out the negative out of these 2 terms already, minus. And so we should divide both of these by -1, so it will become 2x plus 3 here. Always being very careful of this negative sign, because if you distribute, you make sure you get the same thing back. And now out of the first term, do you see that you can factor out x squared? And it'll go 2x plus 3. And then it goes minus of, we could maybe think of there being a 1 here, 2x plus 3. And now we're getting very close because we can factor by grouping this one. It goes 2x plus 3 times whatever's left over, x squared, and then the -1. That's why I put -1, just so it's obvious that that's what's left over when we factor out the 2x plus 3. But this one also, this thing x squared minus 1, this is possible to be factored as x plus 1 and x minus 1. And so what do we have here? We have kind of a telescoping effect of these factors of what we had. So let me just write again more clearly what we got. We had, after the factor by grouping, we had this result like 2x plus 3 and x squared minus 1. And then we have this factor over here as well. Don't forget about the x minus 1 factor that we already had. And so by now we've factored this polynomial a little bit. We've factored it up to here, but then we're able to factor further the x squared minus 1, and we ended up getting 2x plus 3. And then this factor, we can do x plus 1, x minus 1, and then we had this x minus 1 on the end. And so actually this factor of x minus 1, it appears twice, and so we would want to write that one as x minus 1 squared instead. And so we can do this thing 2x plus 3, and then also x plus 1, and then we have this thing x minus 1 squared. And that will be the fully factored form of f of x. That's as much as we can factor it. And then we should use these factors to obtain the zeros. And so of course if we set this factor 2x plus 3 equal to 0, 2x plus 3 equals 0, we can subtract 3, get that 2x is equal to -3, and then divide both sides by 2, we will get that x is -3/2. And I'm going to get a little bit more room here. And then we're able to, that was from this factor by the way. From this factor we can say x plus 1 is equal to 0, so we can subtract 1, so x equals -1, that's another 0. And then lastly from this factor we can say that x minus 1 should also be 0. And so we can add 1 to both sides, get that x is 1. And so we got here actually 3 different zeros, but we should be sure to list their multiplicities as well. So the zeros that we come up with are -3/2, and since that term that gave us the 0 of -3/2, it's to the first power, then we should say with multiplicity of 1. And it's not a problem maybe to just say x equals here as well. X equals also -1. And that came from this factor that has the power of 1 as well, so we would also use for this one multiplicity of 1. And then this factor that gave us the 0 of 1 is squared. And so x equals 1 is a 0 with multiplicity of 2, because this power over here was squared for that term. And so x equals these ones. These are the zeros. This would be our final answer for this problem, the zeros with the multiplicities. And that does it for this video. We're going to pick up in the next video, still talking about 3.4, just tying up a little couple of loose ends, and then we will be carrying on with the next bit of material with the rational functions. And so thank you guys for watching this video, and I'll see you in the next one.